Hello, my name is Michael, and I want to show you a little bit about what I'm doing with my game design project. It's called Cyberpunk City Simulator, and here we go. So here we have a game board. It's very similar to SimCity. You have a rectangular grid. So we're going to build a little city, and it's going to be barely functional. It's going to be the minimum that's required to make a SimCity-like game. And that's basically how far I've got, so let's check it out. So drawing a road is pretty simple. We just draw and click and drag. We're going to unpause it, and we can play the game while it's unpaused. That's totally fine. So the first thing you would do in SimCity is you would make a power plant. In this case, we have a utility zone, and this basically serves as the power zone. So unlike SimCity where you plop down a building, you would actually zone this power plant, and the more space you give it, the more power it generates. But in this case, we're going to make the most minimal size power possible, and it's going to start developing. And here it shows you the number of days that it takes to develop. And let's draw another road further down, and let's draw a residential. So here we have placeholder artwork, and that's the power plant. And that's a house. That's someone's house. That's residence. And we can select it, and we can see that it has 4 floors. That's just temporary. And you can see here the power is being tracked, 596 out of 598 that's being used. We do have a concept of not being able to connect power directly. So like if this road isn't connected to this road and this house develops, it'll say just no power. But then if we connect it back to a road, we solve that problem. Okay, cool. So what about work? These people need to work somewhere, and they have no employment. Well, we have this concept of corporations which provide jobs. In order to have jobs in a brand new city, you have a corporation provide the jobs. Otherwise, the zones, for example, commercial and industrial, are not going to build. And here we have a corporation with an activity called manufacturing. And manufacturing requires industrial zones. So we click on industrial zone, and we zone a new industrial zone. That costs us 12 expansion points. And I haven't really worked on the expansion point system. I'll explain that probably in a later video. But here, we're going to wait until this industrial zone builds up. Okay, and that gives us 2 jobs. In the real world situation, this factory would give like hundreds of jobs, right? But not in this case. This is just a gameplay metric system right now. So anyway, you can see how I zoned a industrial zone, and we clicked on this residence, and there's a path that leads from this residence to this factory, which means there's one person working from here to here. We can click here and see there's two employment out of 4 possible. So that takes up 4 employment of this industrial zone. Same thing with here, this residence is pathfinding to this area. And so these houses will take the path of least resistance, right? Because right now, like if I build a new industrial zone here, so yeah, this guy will switch jobs almost immediately. It's like, okay, we have a closer job here, and we're just gonna go work over there. The game core itself is all in JavaScript. Now this may sound a little weird because JavaScript is not really known for high performance games. What's cool is that I'm running Unreal Engine here, and we're using a plugin called Unreal.js, which allows me to run the game core, the game logic part of it, as a totally headless JavaScript client. And that's really neat because like the JavaScript game rules part of the game, where it simulates every step, is completely oblivious to what Unreal Engine is doing. Unreal Engine is just a skin around which the game is functioning. So it allows me to do a lot of neat things like make the game really moddable. So for example, every rule in the game is expressed as a JSON file here. So here's how a building works in this game. So when I pop a zone, here, some rule is going to look at the zone every day that this passes and say, are you of some type of zone and can you be claimed? Meaning this auto claim rule here says, I have a description that says certain zones automatically turn into buildings. And it's going to go through every zone that's every entity that's a zone but not a building and not a construction. Construction meaning buildings that are currently under construction. And it has these conditions. They are of type residential or of type power. And they have transportation access. If this is all true, then we're going to turn it into a building, and we're going to also give it a construction timer, and we're going to give it an activity. What kind of activity happens at the zone? Is it going to be a habitation? Is it going to be a factory? Is it going to be a power plant? So it's going to be based off of the zone type in this case, which is residential. And here we can see that the zone isn't developing. Well, that's because this rule hasn't passed, which means that it doesn't have any transportation access. So if I plop a road right next to it, this will start constructing. So it added this these two components, this building component, which is 4 floors automatically. So we can select the building, it'll tell us it has 4 floors. And it has a construction total of zone parcels, which is how many tiles it takes up, times 2. So for every tile that it takes up, it's going to take 2 days worth of construction. So larger square footage buildings will take longer to build. And later we can go ahead and modify this and go, oh, we want it to be like times the building dot floors. So it's going to be a volume-based construction timer rather than a area-based one. Okay, so now that we've got that out of the way, once we have a construction rule, or a construction component, what happens to that? Well, the construction rule itself has also a filter, right? It's going to update the construction by looking for anything that with a construction component. It's going to look for the steps. If the steps is less than the total number of steps it needs to build, and then it's going to update it by 1. Pretty easy. It's just a very simple logic that triggers every single update. So the thing that turns it into a building is this rule here, which will look for components of construction. It's going to look to see what constructions have the step equal to the total, and then it's going to remove that component and then add the activity components. And this follows the rule here that if you're a residential activity, then you're going to get these components. You're going to take up this much power, and you're going to create this much labor. Which leads me to my next rule system, which is the resource system. There's a resource system of producers of stuff and consumers of stuff. So labor is a type of consumption that requires a capacity, or has a capacity of, currently it's just the habitation, how many people there are, times 0.5. And so if there's 2 people, that means there's going to be 1 person who's able to work but living there. It's just a thing that's just a rule that we made up for now, but we can change this later. And what's cool about this is that we can define labor as a consumption that consumes a certain type of thing. Here we say it consumes jobs, which is another component. Jobs is here. And the factories here produce jobs. They have a job component. It's not listed here. And so the residences will use pathfinding here. Sorting is using path, and requiring a connection, meaning it can't be on a different island of the map. So, for example, this island here is separated from this island and can't go work over here. If we build a factory here, it can work over here, right? But none of these residences can work over here. That makes sense. So all it is a system through which we can easily create new components and have resources look for one another. Now these 2 won't work right now because they don't have power. I believe this doesn't even qualify as, there's like no employment here. This thing is bugged. But there's no employment here because there's just no power. It's unable to be employed because there's no power. So once we connect it, there, now it's filled. And I believe, there, this guy is going to here for work. I don't know why this display is incorrect, but that's incorrect. So that's basically it so far. And next I want to show you what my next steps are for game design. So here it describes that, we start off the game with nothing, and we have a corporation that's providing 600 new jobs, and we draw a road just like before we saw in the game, and you can zone a power utility, and we zone some factories, and we zone some residences, and they go work over here. Easy peasy. The next couple of steps I want to introduce is this concept of culture. And I talked about that a little bit earlier, and I want to focus on that in a future video. But in this one, I want to talk about, just very briefly, a culture is a mechanic that is embodied by places of work and places of residence. So here, this culture is called the Knights Harvest, and they don't really have an agenda starting out, but they will later on. And they'll have other bonuses to where they inhabit. So everything you see here in the purple is inhabited by that culture, is sort of infected by a culture. And that can spread, especially to places of work, right? So if these people who live here work here, and these people who don't have this culture also work here, that has a virality because they interact with each other, and this culture as a thing that people, as a collection of mores and customs, things that people do, will spread. And that's sort of the simulation layer of the game that I want to get into. Right, so here we're visualizing pollution using a lens. So presumably there would be a UI, and I would click on it, and there would be an area where we see that this is polluted, and the land value will go up and down based on these metrics. So there's pollution, there's going to be crime, there's probably going to be like filth and foot traffic and all sorts of other metrics that I want to add in here. So a good starting point would be this. So the next thing that I want to do is build out the actual visual representation of this using something really, really simple. I don't want to go too complicated, but I want to try to figure it out, at least something solid that I can use for other mechanics like crime and traffic and all sorts of stuff. This pollution is going to be both simulated on a very simple level, where it's going to be a radius between the center of emission, and it's going to fall off outwards. But then these tiles are individually going to be simulated using cellular automata. If you don't know, just look up cellular automata. It's something that's like very simple to do. It's basically a simulation where it checks up the neighboring tiles and decides whether or not it should be on or off. And so using that as a simulation step would create some interesting results where you have the clouds of pollution sort of break off and wander off into the map and eventually fall off the map. So that's going to be pretty interesting because I want a dynamic stochastic system. I want a system in which it's a living, breathing entity. A city is a living, breathing thing, and I don't want it to be super static in those resource type management games where everything is based on what resources you have. Here I want at least some percentage of the game to be out of the player's control. And this is one of those systems that's going to be like that. Anyway, thank you for watching, and if you like this content, you can subscribe to my YouTube channel down below or follow me on Twitter @mflux. Thank you.